honestly just hair-pulling territory. All the meanwhile, the NASA administrator Jared Isaacman is out there making sweeping statements about NASA considering whether Pluto should be classed as a planet again. This result from Salazar Manzano and collaborators showing how the chemistry of 3I Atlas is just so alien to us, so distinct from anything in our solar system. Welcome back to Night Sky News for May 2026 with me, astrophysicist Dr. Becky Smethurst. In this episode, we're chatting about the latest on Interstellar Comet 3I Atlas and its heavy water ratio that's very different to the solar system, plus the extension to the Dark Energy Spectroscopic Survey, and whether Pluto should be made a planet again, and then the massive cuts that have once again been proposed to NASA's budget for next year. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mentioned are all going to be linked in the description down below. But before we get to chatting about the latest space news, as always, let's start with a quick look at what we can see in the night sky in the next few weeks, and start by looking up. First up, you are inevitably going to see a lot of hype on social media and in the news about the upcoming blue moon on the 31st of May. But let me be the one to manage your expectations, because honestly, it's nothing special. At least not beyond like the natural beauty of a normal full moon anyway, because that's exactly what it's going to be. The moon will not look blue, it will not turn blue. The phrase blue moon just refers to the fact that it is the second full moon in a given calendar month. So we had a full moon late on the 1st of May, and now we get another one 29 and a bit days later on the 31st of May. So this is nothing special except for the fact it is relatively rare. You get them once every 2 to 3 years or so, and that's where the phrase once in a blue moon comes from. The thing to actually get excited about this month is the conjunction of Venus and Jupiter around the 8th of June. Now you might remember from last month, I gave you all astronomy homework to do, and that was to look out for the very bright Venus and Jupiter in the west just after sunset, anytime it was clear during May, and to notice how night after night they were steadily getting closer together. These are the two brightest objects in the night sky after the moon, so they should be fairly easy to spot, especially because you've got the glow of the sunset telling you which direction you should roughly look in. So find them now so that you know where to look for them, like from your house, to be able to see them, so that by the 8th of June you can find them really easily and you can admire them when they come just a finger's width apart from each other. This is what's known as a conjunction. And to be clear here, like Venus and Jupiter aren't going to be close together physically in space, right? Because Venus is a rocky planet that's closer in towards the sun, whereas Jupiter's a gas giant that's hundreds of millions of kilometers further away. It's just that from our perspective here on Earth, they happen to be in the same direction on the sky. And I always love when this happens, especially when it's the two brightest planets of Venus and Jupiter, because even people without an astronomy background get to look up and notice it. I remember there was a really good one in December 2019, and there was one quite recently as well, I think, that was sort of the start of 2022. And it's one of these things that you also don't need any equipment to enjoy either. But if you do have binoculars, great, crack them out from wherever you've stashed them in your house and you'll be able to see Jupiter and Venus all in one field of view. Now, technically Mercury is also in the same patch of sky at the moment, but it is a lot fainter and lower down, closer to the sun, so it really gets lost in that glow of the sunset. Again, if you have binoculars, you might be able to find it if you've got a very clear horizon with no trees or buildings in the way. I think the best date to try is the 16th of June, when a tiny sliver of a toenail moon, a crescent moon, will also be nearby and act as a signpost for where to start the search for the faint dot of Mercury. And finally, of course, if you're under a dark sky, away from city lights, and far enough south for it to actually get dark at night at this time of the year, June is when the Milky Way really starts to come into its own for all of you night owls. This looks like spilled milk across the sky. It's the combined glow of billions of stars in the flat disk of our galaxy that are just too far away for us to see individually. The densest part of that is the center of the Milky Way, the center of our galaxy, and you can find it in the constellation of Sagittarius. It contains the teapot shape, which is how I look out for it, and it will rise higher and higher in the south as the nights go on as we get into June. The best view, as usual, will be for all of you Southern Hemisphere stargazers. I have quite an older video on why that is if you want to check that out. But if you are struggling to pick it out with your eye, just grab your phone or a camera and, set a long exposure going on a sort of stable place. Only a few seconds will do, and that should help reveal, where the Milky Way is in the sky, so you can hopefully try and pick it out with your eye. If you can't, just keep snapping pictures instead. You'll be amazed at what your phone can reveal, the incredible detail that is all right there just above your head. All right, that's enough of looking up at the night sky for this month. But before we chat about what's been happening in space news, I just want to ask you to stick with me for 1 minute while I chat about this week's video sponsor, because it is something I really care about. As an astrophysicist, I am used to looking at big, complex problems on massive scales, and I can't help but draw parallels to problems here on Earth as well. Like, for example, how do we feed billions of people? Farming is absolutely essential for that, right? We need it. But at the same time, the current scale of industrial farming has led to a situation where animal welfare is often overlooked. And it's this tension between the necessity and the ethics that I find really difficult to reconcile. Because for every person on the planet, there are around 13 farmed animals. And sadly, the majority of those are still kept in horrific conditions on factory farms. That's why I'm really glad to be working with FarmKind on this video. They're not selling you a product. They're helping people support the most effective and expert-reviewed charities that are working to improve conditions for farmed animals. That includes things like helping move chickens out of cages and getting mother pigs out of crates so that they can actually care for their young. These are practical, evidence-based improvements that really make a difference. And most importantly, FarmKind does not take a cut of your donation. 100% of it gets sent to those charities. Donating just 50 cents a day, which comes out to around about $15 a month, can help save 350 animals a year from suffering. You can donate and find out more information, including exactly what your donation can achieve, by heading to farmkind.giving/Dr. Becky, which I've linked in the description below. And if you head to that link, or if you use my code Dr. Becky, then your recurring monthly donations will get a 50% boost. So thanks again to FarmKind for partnering with me on this video, and now let's come back down to earth and chat about what's been happening in space news in the past month. All right, first up, we've got to talk about the proposed cuts to NASA's budget. And if you sat there thinking, have I got deja vu? I feel like I've heard this before. That's because you have. Back in May 2025, the current US government proposed the largest single-year cut to NASA's budget in history, a 24% reduction for the agency overall, but a 47% cut to the science budget. Many missions that have been decades in the making and the planning were going to get scrapped, all in favour of redirecting money to the space exploration sector of NASA, with the goals of putting humans back on the moon and on Mars for the first time. Thankfully, those proposed cuts had a lot of opposition, and people like yourselves wrote to their representatives and helped to raise awareness, and the budget was thankfully shot down in the US Congress. And instead, in January 2026, Congress passed a budget for NASA that was close to its 2025 funding, with only a 1.6% cut, and also included language to explicitly protect missions that were in danger of cancellation after years' worth of development, like, for example, the Nancy Grace Roman Space Telescope, which is now set to be launched later this year, but at the time had been through decades of planning and design development and even construction. It was pretty much ready built, and yet it was in danger of cancellation. So we all celebrated that victory of protecting NASA's science budget and all of the future science missions that we were excited for and the science that we would learn from them. But then, last month, on the 3rd of April, 2 days after the Artemis II launch, the US administration quietly announced the proposed budget for NASA for 2027. And it's essentially exactly the same as what was proposed last year. It's like they've just gone copy, paste. Now the thing is, you can't tell how bad these proposed cuts are because this budget document, of course, doesn't give you the previous year's budget numbers. That has been a feature of NASA budgets for 60 years to give you that ease of comparison. And it's just so frustrating to see because it just feels like there's been this like orchestrated kind of like, let's stealthily get these budget cuts through so there won't be as much opposition this time, by announcing it while everyone was distracted during Artemis and by hiding, the numbers so that you can't see actually how much of a cut that there's been. But if we do pull those numbers from previous years in, the headline is that overall the proposal is for NASA to get $18.8 billion in 2027, which is a 23% reduction from the 2026 budget, and the science funding is cut by 47% from $7.25 billion to $3.9 billion. Once again, threatening around about 50 scientific missions at NASA and thousands of jobs. Now, I know to you and me in the everyday, this sounds like absolutely crazy numbers, but to put it into perspective, that is only around about 0.35% of the total US government's spending, and it's around 30 to 40 times less than the defense spending, which is pushing closer to $1 trillion. And also, just a reminder, this money isn't just getting launched into space, right? It's getting spent here on Earth, right? It's getting spent on jobs and infrastructure and contracts with other businesses as well. And considering the fact that this budget was announced, off the back of the very successful Artemis 2 mission that had so much popular support, it just feels like the timing is bizarre. Now, if I was going to give them the benefit of the doubt, then maybe you'd think, okay, well, they thought that the previous year's budget would actually get approved and all the work done in this 2027 budget is because they were like, well, it'll be the same as 2026's budget. But then that budget got shot down in Congress back in January. And of course, these budget cuts don't actually affect the Artemis missions. Like the space exploration sector is actually getting a boost in its budget. It's just the science mission funding again, which means that thousands of my colleagues' jobs are once again at risk, whether that is the engineers who are, designing and building the next generation of telescopes, or whether it's the operators of those telescopes, the current generation that are actually, getting the data down from space, or it's the software developers that are producing code to take the raw data from the telescopes and put it in a usable format for the scientific community, or it's the scientists themselves, like me, that are actually taking that data and doing research and writing up what they've found. And then, of course, it's also the science communicators who help to translate what NASA has done for the general public to understand. Because the proposed budget for science communication has been cut by 100%. It is honestly just hair-pulling territory. And of course, the hope is that Congress will block these proposed cuts again. But we need people to make noise about it. So if you're in the US and you care about this, please write to your member of Congress. The Planetary Society have once again collected a load of resources to help you do that, which I'll link below. I'll also link what's known as the skinny budget document that was released by the White House, which details not just cuts to NASA, but other science agencies such as the National Science Foundation as well, and just shows you, just the top line budgets for all the other government departments, so you can see which ones are having their budgets cut in favor of funding others. For those of us outside the US, it's going to be one of those excruciating waiting games, again, just to see what happens and see what the ripple effects then are across the global astronomy and astrophysics community are, especially because in the UK, we're also facing a lot of cuts to the astronomy sector through STFC and UKRI, which I talked about a few months ago as well. It's a very uncertain time for us over here, and yeah, all the while I've just got lots of my fingers crossed that my colleagues' jobs don't disappear. All the meanwhile, the NASA administrator Jared Isaacman is out there making sweeping statements about NASA considering whether Pluto should be classed as a planet again. Look, I love Pluto as much as the next person, but you cannot harp on about Pluto being a planet again and forget about Eris and Haumea and Makemake and Gongong and Kawawa, Ceres, Orcus and Sedna, aka all the other dwarf planets of the solar system. Because yes, there's 3 conditions that you have to pass in order to be classed as a planet. First of all, you have to be orbiting the sun. So that rules out all the moons in the solar system, some of which are bigger than Pluto, including our own moon. Second, you have to be big enough so much that your gravity is strong enough that you become a nice rounded shape rather than a lumpy potato, which is what rules out all of like the asteroids and comets of the solar system. And then third, you have to be gravitationally dominant, right? You have to have cleared your orbit around the sun of anything else of comparable size to you. This is the hurdle that Pluto and all the other dwarf planets fall at. If, in fact, you can even class Pluto as just dwarf planet, because to be honest, it's probably a binary dwarf planet because its moon, Charon, is half the width of Pluto, and the two orbit a point in between them. So I know this has been in the news a lot lately and making the rounds on social media again, but please, if you're going to make the argument for Pluto, you can't leave out the rest of the dwarf planets. Next up, some exciting news from the cosmologists, because last month the Dark Energy Spectroscopic Instrument Team, or DESI, announced that it had completed its planned 5-year survey of the sky. And the numbers are just incredible, because the original plan was for the team to observe and, map the positions of 34 million galaxies. They ended up with 47 million galaxies, plus 20 million nearby stars. That's 6 times more data than all of the previous cosmological spectroscopic galaxy surveys combined, which meant that they can now produce the largest 3D map of the observable universe ever made. And the reason that everyone's so excited by DESI at the minute is because its first years of that survey, that it was, slowly building up the map. It wasn't quite complete yet, but they could still do some scientific analysis on it. Those early years of operations suggested that the accelerated expansion rate of the universe wasn't a constant. So we know that the universe is expanding, but it's not happening at a constant speed. It's accelerating. Now, we've always assumed that acceleration rate was also constant. It's what we call dark energy. But now DESI is suggesting the acceleration might also not be constant over time. The technical physics term for it is that the universe is jerking. I made a short on this recently. Now, the evidence was tentative in those early results, but if this 5-year data set confirms that result as well, we're talking about a fundamental rethink of our current best model of the universe. So we're all on tenterhooks for the data from this 5-year survey to actually be released. It's expected in 2027 at some point, and don't worry, I will be covering it on my channel when this research is published, so make sure you're subscribed so you don't miss out on that. Plus, the great news is that DESI also isn't done yet. It's had its operations extended into 2028, which means it's going to be able to extend that map by another 20%, that biggest map of the universe we've ever made. So there's just going to be, so many unexpected discoveries coming out of this as well, which I absolutely cannot wait for. I'm sure they're going to be fascinating, so watch this space. Moving on now, we've got to talk about the latest research on the Interstellar Comet 3I Atlas, which is showing how it has very different water properties to anything that we've seen before. So to catch you up, 3I Atlas is an object that has formed around another star in our galaxy, but has then been ejected into interstellar space, the space between stars, which has been roving ever since until it happened upon the solar system. There's only been 3 of these objects ever found. The first one, dubbed 1I Oumuamua, was found back in 2017, and the second, 2I Borisov, was detected in 2019. So these are very rare. And these objects appear very similar to comets in our own solar system, but we know that they're from outside of the solar system because of the path that they're taking through the sky, which allows us to work out, that their orbit isn't bound to the sun. They don't loop back around again. So this is why, since 3I Atlas was discovered back in July 2025, it's been all hands on deck to observe it with what feels like every telescope we have, from Hubble to JWST to the JUICE mission on its way to Jupiter, and even Perseverance from the surface of Mars. But now, a paper published by Salazar Manzano and collaborators has revealed something really interesting about the chemistry of water on this interstellar visitor. So Salazar Manzano and collaborators used the ALMA radio telescope in Chile, which is a big array of antennae that work together to make one big telescope, all in order to detect the slight glow that you get from the vibrations of normal water molecules and also something known as semi-heavy water, HDO. So instead of hydrogen atoms, heavy water has deuterium atoms. It's still hydrogen, it's just a little bit heavier because it's got an extra neutron in the nucleus of the atom. Hence, heavy hydrogen, heavy water. So this work by Salazar-Manzano and collaborators is the very first detection of deuterium and heavy water on one of these interstellar visitors to the solar system, which is really exciting result in itself, but also for what it reveals as well. Because yes, comets and asteroids in the solar system have water, and lots of it. Comets are often called dirty snowballs, right? Their water acts like a frozen time capsule of the conditions and the chemistry of where they formed. And specifically, the ratio between the amount of heavy and semi-heavy water, the ones that have deuterium, to just normal water, is really sensitive to the temperature of the environment where an object formed. So the colder the environment, the more deuterium gets locked in and the more heavy water that you get. In our own solar system's comets, roughly 1 in every 10,000 water molecules are this semi-heavy variety of HDO water, meaning that the solar system was probably on the warm side in terms of how hot it was when it formed, at roughly about 30 degrees above absolute zero. It means that the sun probably formed in like a quite a crowded cluster of stars, and that the light from the other nearby stars was able to heat up the gas surrounding the sun that eventually went into forming the solar system, the planets, the asteroids, and the comets. So that's why Salazar-Manzano and collaborators wanted to measure this deuterium over hydrogen ratio to work out, did 3I Atlas form in a very similar environment to comets of the solar system, or are other star systems very different to ours? So here is their detection of the radio glow given off by these semi-heavy water molecules, HDO. And you can see it's a much stronger detection than the glow that's given off by normal water molecules. It made measuring the amount of normal water actually very, very difficult to, get at that ratio. So what Salazar-Manzano and collaborators actually did was infer the amount of water indirectly from the glow of methanol, CH3OH. And this pattern of the glow at specific wavelengths of radio light from methanol molecules comes from the collision of the methanol with other molecules. And the most likely molecule it's going to be around a comet is water. So if you assume that it's water, then you can work out how much water must be there to give you this very specific pattern that's seen in the methanol. Then you can get the deuterium over hydrogen ratio, and you can work out what kind of conditions did 3I Atlas form in. And Salazar-Manzano and collaborators found that the ratio was closer to 1 in 100 water molecules being semi-heavy on 3I Atlas, rather than the 1 in 10,000 that we see in the solar system. You can see that really clearly here. The red dashed lines show the ratio measured for 3I Atlas, one using like the tentative water detection that they could sort of fit, and the other one using that like inferred amount of water from the methanol. That means these ratios are lower limits as well. Likely the value is much higher, hence the arrows pointing to the right. But you can see that that value is over 40 times higher than the ratio in Earth's oceans that's shown by the green dashed line, and 30 times higher than any solar system comets that we've observed. It is closer to some of the ratios we've measured around newly forming stars though, although again, it's still a lot higher. What it means is that 3I Atlas has to have formed in a much cooler environment than any of the comets in the solar system did. So either, you've got it forming around a star that is isolated and not, in a little cluster that's going to provide a lot more sort of energy to heat up the surrounding gas, or it's going to have formed really far away from its star and been ejected early on before things had a chance to heat up. Either way, what this result is showing us is that 3I Atlas formed in a very different environment to the solar system. And really this result from Salazar-Manzano and collaborators showing how the chemistry of 3I Atlas is just so alien to us, so distinct from anything in our solar system. It's just a wonderful reminder that the conditions that Earth formed in might not be so ubiquitous across the rest of the galaxy. And maybe we all just got incredibly lucky. Alright, that's it for night sky news for this month, but I do have a little bit of fun personal news to share. Some of you might have already spotted it, but Sam and I got married last weekend. It was the most wonderful, joyful day with friends and family. It was why there was no video from me last week. It's also why my voice is incredibly croaky for this video from just talking to so many people and singing along to the band. You'll also notice there might be some weeks coming up in the near future where there's also not a video. Again, nothing to worry about. We'll just be on our honeymoon. Oh, so excited. But we're back to the regular weekly content on a Thursday, 8 o'clock UK time, very, very soon after that. In the meantime though, if you snap any pictures of the night sky or if you see any space news stories that you want me to cover in a future night sky news episode, send them my way over on social media because I would always love to see them. But until next time, everybody, happy stargazing. Welcome back to... Still dropping it. Welcome back to Night Sky News for May 2026 with me, astrophysicist Dr. Becky Smethurst. In this episode, that's where the breath needs to be.